Thanks. I hope you're still applauding when I'm done. So it's always interesting to take a look back at where we've been and then take a look forward at where we're going. So today we'll talk about environmental policy. The field of environmental law is so vast now, it's impossible to even claim to be an expert in environmental law. You have to subdivide the field now into many different areas of natural resources and energy and land use and pollution control and species protection, international as well as national. Today I thought, just to try to manage this retrospective, we'd look at the two leading environmental statutes that sort of started the modern environmental era, the Clean Air Act and the Clean Water Act, and see what they've done for us, see what they've cost, see what benefits they've created, look at the approaches that we've taken, those that have worked, those that haven't worked, look at some of the innovations that have been created over this 4-decade sweep of history, and then take a look forward at the problems that we're facing, which quite frankly dwarf the problems that we've had. And the challenges that lie ahead are unlike anything that we've dealt with in the past. So this is where all of the young people in the audience come into play, and particularly the Thayer students, because finding solutions, practicable, workable solutions to these daunting environmental challenges we're going to talk about is right at the center of how we're going to manage our way successfully into the future. One other kind of preliminary point is that these issues are once again bubbling up to the surface as we approach the 2012 presidential and congressional elections. And already we're seeing environmental issues which have not up till recently been at the forefront of discussion about the electoral issues of the upcoming campaign. They're starting to bubble up to the top. The president's decision on the Keystone Pipeline, the president's decision not to go forward with ozone, new ozone rules, moves in Congress to repeal major parts of EPA's legislative authority to deal with a wide variety of environmental problems, ideological divides over environmental policy that we never had in the early days of environmental law in this country. So we're at, as the legend goes, an interesting point in time as we confront some of these issues. But for now, let's go back to the beginning. Wrong way. Notice something about these three gentlemen, in addition to the fact they're three gentlemen. Notice anything interesting? They're smiling. They're doing something they're proud of, and they're all Republicans. Now, this is not going to be a political tirade. Relax, okay? But there is something significant to point out about this. The man in the middle is the environmental president par excellence. No other president in the history of the United States signed more environmental legislation than Richard Milhous Nixon. Okay? And he did so in an era where it was wildly popular to do so. The Endangered Species Act, which he insisted be passed unanimously. So, in 1973. We're in a different place now. But let's not forget that at one point in this time in this country, environmental issues were not partisan issues. They were not. They were consensus issues. That's what we had before the Clean Air Act. This episode killed 20 people and put 7,000 people in the hospital in one day. That was the United States pre-environmental pollution control. That's what LA looked like. Some would say not a whole lot better, but that's not true. It is a whole lot better. If we want to know whether environmental regulation is important or not, take a trip to Beijing. I've been asked to go and spend 6 months in Beijing, and I have declined. I have a family. I'm not taking my family to Beijing. If they want to do webinars, I'm your guy. Spend 6 months in Beijing? No. Here's another way to look at what the Clean Air Act, which is the most comprehensive, the most expensive, and from a public health standpoint, the most important single environmental law we have. There's more exposure, human exposure to air contaminants, airborne contaminants that do damage to bodily organs than any other environmental problem we have. It's way beyond hazardous waste disposal, way beyond water pollution. Not to say that those problems aren't serious in certain instances, they are. But in terms of the number of people exposed and sickened and dying from environmental harms, airborne contaminants lead the pack. So this is the really, centerpiece statute of American environmental law. And note some interesting things here. You want success? Those are the 6 most common pollutants. We call them criteria pollutants. These are not hazardous air pollutants. Talk about that in a minute. But these are the things that make you sick. These are the fine particulates that get in your lung and cause cancer. These are the ozone precursors that trigger asthma attacks. These are the things that cause cardiopulmonary disease, that shorten people's lives, that make people go to the hospital and miss work and not be productive. This is lead that lowers the IQ of children so they can't learn and have no chance at a decent life and decent work because they're exposed to too much lead. So these 6 common pollutants have declined by 63% over this period of time since passage of the 1970 Clean Air Act. Not a bad record. Not nearly enough. We're not there yet. There are still too many excess deaths and disease and sickness and impairment in a modern nation that prides itself on a high quality of life. We still have a long ways to go on these various pollutants. Never mind the new pollutants that we're having to deal with, CO2 among them. But a pretty good record. Now, for those who question whether environmental regulation can coexist with economic development, take a look at the top line. That's what our GDP has done over that same period of time. 204% increase. Some might find that a rather disturbing number. How much growth can we stand, you might be thinking. But to those who would suggest that environmental regulation is killing growth, killing jobs, the data doesn't support that. Some more data. Look what's happening with energy consumption. We could cut that in half. We could cut that in half by 2020 with a 17% return on investment. If we had the policies to make that happen, to change the way we use energy and to change the way we invest in energy. If we put the investment in energy efficiency, the studies show you can cut it in half in the United States and get a 17% return on investment because of the long-term operational savings you get from energy efficiency, heating, cooling, etc. CO2 emissions, we'll talk further about that later. Look at this. All of the stuff reducing emissions from these emissions come from both stationary sources like power plants and tailpipes. These reductions notwithstanding this enormous increase in vehicle miles traveled. So we're traveling more, but polluting less. Suppose we had fuel efficiency standards of 50, 60 miles per gallon. The Obama administration is trying to put in place a 54 mile per gallon fuel efficiency standard for 2020 right now. All of the automakers in Detroit have signed on to that deal. Isn't that a revolution? They had to go bankrupt before they finally saw the advantage of moving to fuel-efficient vehicles. But they're there now. They inked a deal with the president supporting a 54 mile per gallon fuel efficiency standard for the United States. That's some good news. Population, still increasing, but not exorbitantly here. Let's take a closer look at some of these specifics. And now I'm just going to give you a few examples behind these large charts. Lead, leaded gasoline. That's what powered our GTOs, which is what I used to race around in when I was a kid and had hair and no brains. Now I have no hair and some brains. This is one of the success stories of the Clean Air Act. One of the most startling success stories of the Clean Air Act. And you can see emissions, thousands of tons per year on this graph. Here's where we were when the Clean Air Act was passed. These are the different sources of lead. And here's how we gradually brought that down to essentially a negligible level of lead. Never would have happened without the Clean Air Act. Simply wouldn't have happened. I don't know what that graph would look like. You could imagine. You can only imagine what it would look like. It's a neurotoxin, and it has particularly grave effects on young children. So these are just some details of the emissions reduction over that period of time. This is a report EPA did in 1997. Congress, right from the beginning, from 1970, told EPA, we want you to periodically assess the costs and benefits of these laws to the American people. And we want you to do it in a structured way with independent review, multiple layers of peer review, and we want you to comprise a panel that we will approve of experts outside the agency, from academia, from industry, who will review what the Clean Air Act, and they did the same for the Clean Water Act, is doing for the American people. How much is it costing? What are its benefits? How can it be made better? Is it based on good science? All those sorts of things. And this was the first report, first major report that the agency submitted. This is what it did. 205,000 premature deaths, 672,000 cases of bronchitis, heart disease, asthma, cardiovascular, lead effects, respiratory illnesses. This is what the economists call externalities. This is what the price of electricity for coal doesn't count. But these are real costs. And they're not just real physical costs, human costs, they're real economic costs. And this is the latest Office of Management and Budget, the green eye shade types, the Cass Sunsteins of the world, the people that are enamored of cost-benefit analysis, quantitative cost-benefit analysis. Very skeptical of environmental regulations promising to do wonderful things for the American people and not truly accounting for their costs and documenting and demonstrating in a monetary sense their benefits. And this is what OMB has to say about the effect of the combined air and water regulations between that decade, 1999 to 2009. Aggregated annual costs, 26 to 29 billion. That's the figure that you'll usually see from the Chamber of Commerce. That's the one that you'll read about in the rhetoric from the campaign trail. That's the outrageously expensive, crippling the American economy number that you'll hear about from critics. But how about this number? What about the benefit side of the equation? What are the benefits that you're getting from that obviously significant investment and cost. And that's what OMB, not prone to inflate values, says. And these ranges are huge because, of course, the variables are incredibly complicated, and the assumptions that you make are critical. And depending on your variables that you input to your model and the assumptions that you make, you're going to get a large range. But even at the bottom end of the range, look at the difference between costs and benefits. This is another pictorial. It helps you see a little easier what we're talking about. So these are costs and benefits, directed benefits for these study target years, billions of dollars. These are all from EPA's air and water quality regulations. So if you want to rely on data, independent analysis that's peer-reviewed in published journals by credentialed economists, that's what they'll tell you about environmental regulation, health-based regulation. It simply isn't true that the benefits don't, that the costs outweigh the benefits, or that these are, quote, not worth it, these regulations, from an economic standpoint. It's not true. That doesn't mean that it's not a political issue. It just means, as a rational issue, it's not true. Also doesn't mean the regulations couldn't be improved. It also doesn't mean that those costs are too high. It doesn't mean that either. There's no regulation in the world that can't be improved. There's nothing in the world that can't be improved. I could be improved. But the point is that, is this a good social policy to have control and regulations on these pollutants? I think the data is pretty clear. Let's take another example, one that's had dramatic effects here in our biome of the world, in New England, in the northeastern part of the United States. Of course, we're at the end of the tailpipe, right? We get it all. We get all the emissions from the coal plants in the Midwest and the cars in the south and the northeast. It all flows up because the prevailing winds come in our direction and deposits it on us. And this is what happens with acid rain precursors, sulfur dioxide and nitrogen oxides. And this is some of the forest damage that it does. And of course, it does even more severe damage to alpine lakes in the Adirondacks. It's basically eliminated the brook trout from most of its historic range, our native trout species, freshwater trout. And so it was a huge problem. It was a problem in Europe before it was recognized as a huge problem in the United States, but it finally, through the 80s, gained traction. The first response of conservatives in Congress was, there ain't no such thing as acid rain. The second response is, it's not being caused by our power plants, it's being caused by Canada. And the third response was, it's too damn expensive to deal with it. Just think of the one famous estimate by an OMB director calculated what it would cost per pound of trout to reduce acid rain and said it's not worth it. But we did do it, and this is one of the first major innovations of the Clean Air Act. We did it with something called cap and trade. We did it with a market-based mechanism. We did it with selling pollution rights. That was hard for a lot of people to swallow, still is. But from a cost-effective standpoint, it was phenomenally successful. As opposed to the old way of command and control regulation mandating technologies to scrub emissions of sulfur dioxide out of power plants, this approach said to the power plants, your target is 10 million tons per year reduction in SO2. The region of the country that you have to achieve this is the eastern United States. Here are the boundaries. There are about 300 power plants within that region. We know each and every one of you because you're subject to regulation under the Clean Air Act, an important point not to forget. And we are going to tell you, you have to reduce your emissions to achieve this overall goal of 10 million ton reduction, but you can do it however you'd like. You have the choice of figuring out what's the most cost-effective way for you to do it. Even with that approach, the cap-and-trade approach that was adopted by George H.W. Bush, it was a Republican idea, and it was adopted by the Congress in 1990. wild estimates of what it was going to cost to do it even with this flexible market-based approach. This is the reality. These were the projected costs. This is where the actual costs came in. And this is what happened with emissions in response to that. So the acid rain program, of course, is everybody's model now for cap and trade, and people have talked about applying it to carbon and CO2 and climate change. It's a whole order of magnitude different when you're talking about dealing with carbon than you are talking about SO2. We're not talking about a discrete number of sources when we're talking about carbon like we were with SO2. And we aren't talking about a universe of sources that are already subject to control, to regulation, to permits, to monitoring, to reporting, to enforcement, all of which is true with acid rain. Don't for a minute mistake what was done with acid rain as free market approaches to pollution control. No, it's still regulatory approaches. It just has this feature, this important flexibility feature in it. Whether or not you can actually adapt this relatively simplistic model of cap and trade to carbon is a big, big question mark, but many people think you can. Here's another look at what happened during the acid rain program. Again, you know, tracking domestic product, it didn't slow down one bit. Electricity generation continued to climb, and SO2 dropped. So, point being, you can attack these problems at less cost than people think, without impacts on economic development, and you can achieve your objectives at least as stated. Now, one thing about acid rain to keep in mind, which is important for climate change, is the cap and trade program only worked for SO2 because it was a stationary source problem, and like I said, we knew where the sources were. Nitrous oxide, nitrogen oxides, that's tailpipe stuff. You can't do a cap and trade very well, very easily, for tailpipes. So we didn't. So we didn't address the second precursor of acid rain, and as a result, the improvement that we should have seen in the forests and ponds and lakes of the Northeast has not been as successful as hoped. We're going to have to do more with NOx to do that. What's the next major problem and innovation that occurred under the Clean Air Act over the space of the last 4 decades? Stratospheric ozone depletion. Okay, ozone depleters, and you know, a pictorial, Justice Scalia didn't understand any of this during the argument in the Massachusetts versus EPA case, so I sent him this graph. I never got a response, but he acknowledged during the oral argument he knew nothing about the atmosphere, so I sent him this to sort of explain it to him. He got confused between, he thought we were talking about this when we were talking about CO2 emissions, and we were actually talking about this. This is where we live here. And in between these layers of the atmosphere, of course, is the ozone layer that protects us all from ultraviolet radiation. And Molina, Dr. Molina at University of Pennsylvania was the one who first blew the whistle on stratospheric ozone depletion. James Hansen was the first scientist to blow the whistle on climate change in 1988. James Hansen's been ignored. Thank God Molina was listened to, and we reacted to it. It's not really a hole. It's not really a hole in a donut kind of thing. It's a thinning of the ozone layer, and there's a very complicated formula that I don't understand to determine how thick the ozone layer is. But the important point is it keeps getting bigger. And year to year now, it fluctuates. So, you know, and even though this is a big success story in terms of reducing the ozone depleters that are causing this problem, like so many environmental problems, they're stubborn little things to fix. Even though you think you're well on the way to fixing them, we have not fixed the hole in the ozone. Now here's the good news, if you can think of it that way. It's guarding us from even worse climate change, because it's allowing cooling of the globe, an escape of gases that would otherwise be trapped, and so it's masking the true effects of the CO2 emissions that we're putting into the atmosphere. But as this heals and closes, of course, it'll go the other way. Another kind of perverse problem in that regard is SO2 and the other aerosols that are being emitted all over the world, those are also a cooling agent that's masking the true effects of climate change. And as we improve controls on those aerosols for health reasons and other environmental reasons, climate change will get worse. These problems are interconnected. So, this was a good news story. This is the single most important international treaty we ever signed and ever negotiated in Montreal in 1990. And then it was implemented through the Clean Air Act, hence the reason I'm raising it here. This was a phenomenal success story. These are the ozone depleters, the chlorofluorocarbons, some of which are also, by the way, greenhouse gas agents. And if we had not listened to Molina and the other scientists and gotten serious about eliminating these ozone depleters, this would have been the curve we were looking at, and that satellite image I showed you would have been one hell of a lot bigger, I assure you, than the one that we have to deal with now. As a result of the Montreal Protocol, this is what has happened to these ozone depleters. Now, don't get too excited about that, because this was a relatively simple problem to fix. All we needed was a substitute for chlorine-based agents for coolants and other things. And DuPont was only too happy to find us one and patent it. So this is a good news story, but even though a big, big problem, it could have been a serious problem, a relatively easy problem to fix once we got serious. How about mercury? What's the major source of mercury? Our old friend coal. Coal-fired power plants, by far and away, the largest sources of mercury. A neurotoxin with serious health effects on humans, and even probably more serious effects on ecological and ecosystems, ecological integrity. It's not elemental mercury that's the problem, the stuff you play with in the lab. It's methyl mercury. It's the process, the change that takes place in mercury as it goes through aquatic systems and goes into a soluble state and becomes available to other organisms, and then the kicker bioamplifies as it moves up the food web to the top of the food chain, which is us. In between would be eagles and ospreys. But as it begins to move up through this food chain and concentrates in the flesh and organs of fish that we eat, it becomes a serious problem. And here we are at the end of the pipe, and all of the fish in New England and the Northeast have mercury advisories associated with them, and these are some of the other areas that do as well, notably the Ohio River Valley. Here are the top 25 mercury emitters in the country, and we're downwind of most of them. This is a hazardous air pollutant. So another major feature of the Clean Air Act is that it created in 1990 a much more rigorous program for control of hazardous air pollutants. The sad story is it's taken 20 years to implement that program due to politics, changing administrations, shifting priorities, etc. We should have been well along the way of ridding ourselves of mercury emissions long, long ago. The technology is not the problem. The will to implement and enforce the technology and require the technology has been the problem, and to this day, it's still not clear that we're finally going to get the mercury rule that we've been waiting for 20 years that would reduce mercury emissions by 91%, according to EPA's Science Advisory Board. But the law provided for it, and if the law had been properly implemented, it would have, by now, done it. That brings us right up to today, folks. So here we are still working on modern air quality problems, ozone, smog, O3, tropospheric ozone. We like ozone when it's in the stratosphere. We don't like ozone when it's in the troposphere. It's a real health problem. EPA's Science Advisory Board said the standard that the Bush administration adopted was not protective of public health, and EPA had to lower it to at least 65 parts per million. EPA with Lisa Jackson right here proposed that standard and said, I don't have any choice. They were also in litigation under a court order to come up with a science-based standard, and Lisa Jackson said, even if I didn't want to set this standard, I don't have any legal or scientific basis not to. I have to set the standard at this level. She was overruled. Plain and simple. And it's pretty clear from the coverage, at least, of the story that politics in the 2012 election entered into the equation at the last minute. When the rule was pending at the Federal Register, it had to get past the White House, and it didn't. It was stopped, and it was kicked down the road until 2013 after the election. This is what did it. The Chamber of Commerce, the American Petroleum Institute, the fossil fuel industry got together, financed the campaign, hired the experts, hired the lobbyists, and produced the maps and showed them to Bill Daley and said, this is what you're looking at in 2012 if you go forward with this policy. The red areas are the areas that will not be in compliance under your standard. And you can be sure that we'll let everybody know what the effect of your decision is on this case, on their jobs and their communities and their economy if you go forward with this rule. And that was enough to do it. That scotched the deal. Many people thought Lisa Jackson would resign. The president obviously pulled the rug out from underneath her, embarrassed her. This was a signature issue of hers. It was a children's issue for her. And a lot of people begged and pleaded with her not to quit. She came close to it as a matter of, quote, principle. Ultimately decided EPA would be a lot worse off if she did, so she didn't. But that was her statement. Let's move on to the Clean Water Act. That was America before the Clean Water Act. That's the Cuyahoga River, the famous Cuyahoga River in Cleveland. And that events like that occurred quite regularly. One of them occurred in 1969. At the same time, another event, which is a little later in the slides, but I'll tell you now, occurred, and that was the largest single fish kill that ever occurred in the history of the United States. At a lake in Florida near Tampa, 26 million fish died in one event, 1 week, from pollution, low oxygen, and so forth. That's the Cuyahoga River today in downtown Cleveland. Looks a little better. You can be sure that the Clean Water Act did that. You can be absolutely rest assured the Clean Water Act did that. The states had total authority over water quality prior to 1972 when the Clean Water Act was passed. So burning rivers, those were on the states. Lake Erie being declared dead, that was on the states. 26 million dead fish in Florida, that was on the states. Oil platforms blowing off of Santa Barbara, California, that was on the states. So the states weren't getting the job done. And the federal government stepped in. Recognize that? Does that look familiar? A few of you been on the river lately? Pretty scene, isn't it? Beautiful, bucolic America. I just found this one for kicks. That's looking from Ledyard Bridge. But it wasn't always so pretty. They called the Connecticut River the best landscape sewer in America. These signs were prevalent all up and down the river. Check it out. Whoops. No swimming, no wading, no kayaking, no fishing, no nothing. That was the Connecticut River before the Clean Water Act. That's the Connecticut River today. If you hurry, you can still put a bid on this property. This is just the land, folks. Ain't no house there. So, does clean water have a value? I think maybe we can agree it does. That was the famous fish kill. I just grabbed the cover shot of the report. That's what it looks like today. It's a functioning lake. Still has a few fish kills. but a lot better. How about wetlands? Wetlands perform all kinds of wonderful functions for water quality. They're nature's kidneys, right? They filter pollutants, they buffer streams and lakes, they take out even toxics. They can fix toxics in the fibers of wetland vegetation plants. They store floods. They're nature's sponges. They reduce flood peaks. If you don't drain them all, you wouldn't have such horrible floods in a lot of places in the country. Think Mississippi River, think Louisiana. We've destroyed almost 60% of the nation's wetlands. And at the time the Clean Water Act was passed, we were destroying them at the rate of hundreds of thousands of acres per year, about as fast as we could. Like that. Wetlands, over 50% of endangered and threatened species depend on wetlands. Wetlands are nurseries, particularly coastal wetlands, for incredibly important commercial species of fish and shellfish. They are carbon stores. They store enormous amounts of carbon and methane. They do fluctuate in the cycles of carbon and methane, but over time they store and sequester far more carbon and methane than they produce. So they are an invaluable safeguard against climate change. Lots of goodies come from wetlands. The good news is that this figure here is actually now down to something like 13,000 acres per year with the implementation of things like this. Wetland mitigation banks, which create the opportunity to offset losses of wetlands by restoring other wetlands. Creating wetlands is a little sketchier, not really very reliable, but restoring wetlands, that's a proven, demonstrable technique if it's done right and if it's monitored, if the details are all in place, you can do it, and you can create offsets for wetland loss. That's what's called no net loss, and all of that came as a result of the Clean Water Act. One of the biggest single improvements delivered by the Clean Water Act was getting the poop out of the water. Sewage treatment plants. And these are expensive items, like this. $77 billion investment. It used to be a 90-10 matching grant program from the federal government to the states. These sewage treatment plants that we have today would not be there without that 90% federal match. In the Reagan years, that loan program was abolished and replaced with a revolving fund, which continues to this day, not nearly at the rate of investment of before, but still helping try to maintain these plants, which are aging, deteriorating, in bad need of upgrades, repair, replacement. And that is a fairly pricey item. If you want water quality, you're going to have to pay for it. It isn't going to happen by itself, by osmosis. It's going to happen because you invest not only in technical means, waste treatment technology, but buffer strips, stepping back from the river, letting natural riparian zones do the work that they're supposed to do and keeping bad things, sediment and other things out of the water, cooling the water, maintaining habitat, staying out of the floodplain, letting floodplains be floodplains. There's lots of things that you should be doing to avoid having to spend oodles of money treating water that nature can treat with the systems that ecosystems have in place. Those are the sources that are addressed by the Clean Water Act. The obvious point sources and the less obvious non-point sources. The history of the Act has been, we've been very successful at dealing with point source pollution. Industrial point sources have reduced their pollutants by over 90%. And waste treatment plants, if they're kept up, are doing a good job too. It's the non-point sources that are killing us. 40% of the nation's waters don't meet water quality standards, not even basic ones like fishable, swimmable. And it's because of the non-point source. It's the runoff from farms and fields, logging jobs, farms, dairy farms, our dear beloved dairy farms in Vermont, and so on. These are the major problems that we have not fixed with the Clean Water Act, and the reason is quite simple. The Clean Water Act exempted them from permits and regulation. It provided a pittance in terms of financial assistance. If you're not going to regulate the problem and require those that are causing the problem to stop it or fix it, then you're going to have to create a very large fund of money to pay to fix it that way. It's one or the other. It doesn't fix itself. We haven't done either yet for non-point source pollution, and it's a huge, huge problem, and here's the best evidence of that. So this is one of the largest watersheds in the world, and it's heavily agricultural as well as industrial, and it contributes nutrients down to the Gulf of Mexico, primarily phosphorus and nitrogen. Nitrogen is the limiting agent for algal growth in salt water. And when you fertilize a water body like the Gulf of Mexico and you create lots of algae which die and decompose and take oxygen out of the water column to decompose, then you rob the water of its oxygen content and you get what's called hypoxia down here. The dead zone of the Gulf of Mexico. Now, there are 400 dead zones around the world. So this is a global problem. Long Island Sound has a large hypoxic area every summer. This is a big guy, okay? This hypoxic zone ain't no small smear. Texas, Louisiana, Mississippi, this is a big, big chunk of the Gulf of Mexico that's dead of life, devoid. And it's getting bigger, not smaller. And it's a result of nutrients that are not controlled from the entire watershed. And it's a mega problem. It's a national problem. States can't fix it. They don't have the power to fix it. So this is one of the big unresolved ones, and this is what it does. This is a fish kill in Plaquemine Parish, 2010, from low dissolved oxygen. Fish need oxygen. Here's another one that we've struggled with. Invasive species, aquatic and terrestrial. But the aquatics in Great Lakes are out of control. There's 65 of them rampant in the Great Lakes, most coming in on ballast water, which until lawsuits were filed, were not regulated under the Clean Water Act. Now they are. Now gradually we'll start addressing the problem of ships calling on ports in Singapore and the Far East and taking ballast water next to outfalls from those parts of the world with God knows what in them, and bringing that water into the Great Lakes and discharging it to get rid of the ballast water. That's been the biggest problem with aquatic invaders in the Great Lakes, and it's a huge, huge problem. These guys are the next big problem. These are the famous Asian carp that are within 1 foot of the Great Lakes, of Lake Michigan. They're only being kept out by a Corps of Engineers canal with an electric fence across it. And these guys can jump. These are 100-pound fish that knock people out of their boats, ladies and gentlemen. There is no control agent other than eating them, and we all ought to be eating a lot of them. And they are headed for the Great Lakes. Okay? They've come up from Louisiana, and they are headed. They may be in the Great Lakes. According to Michigan, they are. They're looking for DNA samples to prove it. Let's look ahead a little more. Like I said, the problems of the past look like peanuts compared to where we stand in the moment of time right now with climate change. The greenhouse effect, the trapping of all these 6 greenhouse gases are the ones that have been identified. There are more that have been identified, that have been subject to international treaties like the United Nations Framework Convention on Climate Change, Kyoto Protocol, and now our Clean Air Act as a result of Massachusetts versus EPA decision. There are 6 of them subject to some form of control, but there are more than that. But, you know, we're having a hard time coming up with a name for this thing. We started off with global warming, but, you know, as Alex said and others have said, that sounds kind of good in New England. That could be a good thing. So you know, in terms of messaging and framing, maybe that's not the right message to be telling people. Global warming might sound pretty good. Like a little thermostat, turn it up a little bit, no problem. So scientists said it's really climate change. It's changing the climate. That's what it is. Well, yeah, but change could be good or bad. And in fact, in some ways, climate change is both good and bad. Good in the short run anyway, and maybe increase crop production, you know, in certain parts of the world, and then crash. But that doesn't quite do it. So John Holdren, President Obama's science advisor, said, no, we got to call it climate disruption. That's really what it is. It's creating weird weather, extreme weather, unpredictable weather. Crazy things are happening. And it's not just weather, it's ocean acidification. The ocean chemistry is changing as a result of CO2 emissions. So we can't find a term for this thing. But here's one thing you can say. You want to talk deep history with me? Paleoclimate? How does 552 million years sound to you? So this is the climate record that the climate scientists have recreated for this period of Earth's history. And the thing you want to just sort of keep your eye on is, have we had wild swings in the weather and the climate on Earth? I think so, maybe, yeah. You could call that wild swings. And then look at this. The Holocene. The most favorable climate conditions ever on the history of the Earth so far as we know for human life and other life. We've been in a relatively calm period. Incredibly calm. And you know what? We're out of that now. This next bar here, this, the scientists say, is the Anthropocene. This will be us. We're determining the climate at this point. We've taken over the controls. We're flying the ship. Where? Well, this is the famous Keeling curve. Charles Keeling started it 50 years ago on an observatory in Mauna Loa, tracking carbon dioxide emissions. This stopped in 2000. Well, we're here now, this year, 390, and climbing. Last year, set another record for CO2 emissions globally in the face of an economic downturn. A new record for CO2 emissions. Young folks in this room, this is your curve. This is the curve that you've got to deal with. We gave you this, my generation. We gave you this. This is our legacy. This is what you're living with. If you don't bend this curve in your lifetime, you're looking at serious changes on the Earth. That's the challenge. Human fingerprint, you want evidence? The scientists have looked at this from every way possible. I will pay anybody my 403B retirement account, which ain't much. But I'll give it to you. Plus my car, not my dog, not my kids, not my wife. But I'll give you everything I got if you can find me a study, peer-reviewed, published in Science magazine or a comparable journal, that disputes the findings of the IPCC. Please, do it. Find it. Find the theory. Find the data that explains what's happening, that takes the human equation out. Please, God, do it. Nobody's done it yet. Nobody's taken me up on that. I hope you do. This is the path we're on. Is that a signal? This is the path we're on. Some people just throw things at me to stop me. My class does that. So this part of the talk, and then I'll end on a happier note, but this part of the talk is the truth. A lot of people say we shouldn't be telling the truth. It just scares people and makes them angry. I'm sorry. You're all adults. You've got to hear the truth. So this is where we are, folks. This is the Hadley model from the Met Center in Great Britain. You can discredit it if you want, but they're the best. This is the path we're on right now with emissions, 132% increase by 2050. And that's what you're looking at. I mean, that's totally beyond the realm of any human experience. It's totally beyond the realm of science to predict what the world would look like. There's no way of knowing other than the fact that another study out of this office said at 7 degrees Celsius, most of the world will be uninhabitable by humans. Now, that's just a prediction, a guess. It's bad. That's all we need to know. Suppose we got a late start and then a slow and steady decline in greenhouse gas emissions. Well, that puts us on this trajectory over here. That's not a good number. That's not a good number. How about if we started early, like last year, but we had a slow decline, like maybe 2% a year? What would that do? Leveling off to 1990 levels of greenhouse gas emissions, which is the Kyoto Protocol target, by 2050, let's say. What if we got onto that kind of a glide path? Oh, holy mackerel, we're still up here. If you want a reference point, the Copenhagen Accord says 2 degrees Celsius is the target. That's what the scientists say. We think maybe, the consensus of scientists is, we think maybe 2 degrees Celsius will avoid dangerous interference with the climate. We think. James Hansen says, no, it's 1.5. Whatever it is, 1.5 or 2, we ain't going to make it with, starting last year, steady decrease. We can't get there. Okay? How about early and rapid reduction? This is like we're on the order of 6% a year. Well, you got sort of a shot at it. But it's not happening. It's not close to happening yet. So what does that mean for air and water? What does climate change mean? It means so many things it's beyond talking about today. It's just too big a topic. But a few things. It's going to have impacts basically on every aspect of water. River flows. One thing that's crystal clear is there's an extra 2% of moisture in the atmosphere, which is growing every year by about the same. That's measurable, documentable, empirical data. So every time a new front comes along and encounters that much moisture in the atmosphere, you get heavy precipitation. Sometimes it's rain, sometimes it's snow. And no, it's not funny to say, look at all the snow in October in Connecticut. How could it be climate change? Ladies and gentlemen, it is climate change. That is consistent with the models predicting heavy precipitation events from the extra moisture in the atmosphere. Absolutely consistent. Irene, the high rainfall events, absolutely consistent with the models. Was Irene caused by climate change? Wrong question. Wrong question. Will we get more Irenes with climate change? Right question. Yes is the answer, the scientists would tell you. The dice are loaded. That's the way they talk about the human effect on weather events from climate change. We've loaded the dice, so we'll get more of those flood events. Snowpack, no question about it. It's declining. 80% of the water supply in the western United States is snowpack. 80%. Phoenix, Tucson, Las Vegas, Los Angeles, San Diego, Denver. Snowpack. And it's declining rapidly. Hydroelectric power. You don't have water at the right time, you don't have hydroelectric power. China is experiencing dramatic reductions in hydroelectric power generation as a result of lowered stream flows. Floods, we've talked about. Drought. Take a look at what happened in Texas this year. Rick Perry's running around the country saying climate change is a hoax. His state is on fire. They had a record drought again this year. On fire. A steady 107-degree temperature 2 months in the summer this year. Wildfires everywhere. Arizona, that's consistent, absolutely consistent. Look at any climate change model and you'll see it. And so on and so forth. Sea level rise, you're going to armor the whole coastline. You're going to build dikes and seawalls all up and down every coastline in America to keep the ocean out, or are you going to move out of the floodplain, and where are you going to go? Water quality, more runoff, more contaminants running off from high rain events, and so forth. So serious problems. The Dust Bowl, human-caused catastrophe. Human-caused catastrophe. USGS, U.S. Geological Survey, says the desert southwest of the United States will be a permanent dust bowl before the end of this century, given the trajectory of climate change. That's not Greenpeace. That's not environmental lawyers. That's the United States Geological Survey. They just measure things. Stop or 5 minutes? A few minutes. This is the graph you need to know about. You see, this is the thing. You move the median. You're all math majors in here. This is what happens when you move your curve slightly. Move the median increase slightly. This is why we're getting all this crazy extreme weather now. Because that's what we're doing. We're moving the median temperature. Ocean impacts, CO2, attacking the base of the food chain, the calcification formation organisms of the ocean, changing ocean chemistry, changing the marine ecosystem. If you don't believe in the temperature models, explain this. Why is ocean chemistry changing? It's a base environment. It's becoming acidic from carbonic acid. And then finally, as if it wasn't bad enough already, we get the latest World Energy Outlook from the International Energy Agency. Again, this is hardly Greenpeace or wild, fanatic environmentalists. These are cold-eyed engineers trying to meet energy demands of the world, and this is what they're saying. We've got 5 years to make the investment in clean energy, or it's over. It's a lock-in that's going to take us to 3.5 Celsius minimum. 5 years. They've stopped fooling around saying we need to get busy and get started. They've started saying we have 5 years to shift trillions of dollars of investment away from fossil fuels and towards renewables and efficiency. The good news, and this is just one example, but he's an engineer, so I thought it was appropriate. Everybody knows Amory. He keeps trying. The technology, the know-how, the innovation to do this is at our fingertips. We know how to do this. We know how to make this transition. We can make this transition. It can create jobs. It can create innovation. It can create products. It can improve balance of trade. It can do all of that stuff. And it can save the climate. The technology, the know-how is not the problem. The money is not the problem. It's the will. It's the political will. It's a cultural problem we face. The environmental problems of the future demand that we attack root causes. All of the laws that I've been talking about and examples I've been talking about are treating symptoms of problems. Putting technology on smokestacks and outfalls. Reducing emissions. Those are symptomatic approaches. They won't work for this problem. They won't work. This has got to be an attack at the root causes. The economic drivers of climate change have to change. They just have to change. This is a book, recent book, very readable, eminently practical, very engineering oriented, very techie oriented, that shows how to do it. So here's where we are. Here's where we are as a society. And there's our choice. Yes, we can, but let's not let this happen. Okay, thanks a lot. Okay. How do I do that exactly? There's probably a faster way to do this, but I'm stupid. lot of slides, huh?
Here, it will get you over here, and you just go to.
I think I just had it.
Oh, you did?
Yeah,
This one?
it's this one.
Yeah, you click on it.
Yeah.
Is that the one?
No, it's this one.
Yeah.
This one down here.
Oh, this one. Okay. And view. Slideshow. Show, where is the slide? Show.
So I think, in my opinion, I don't think it's very appropriate to say Beijing is a terrible city to live. I'm from an even worse polluted city in China than Beijing. So I spent 18 years there, and I think I'm very healthy now, so I can do half marathon in the States. So I think, yeah, so the fact that the Chinese people do not get sick, in my opinion, simply means that we probably have a stronger immune system. And I admit that China is heavily polluted everywhere. But China is the second largest economic body in the world. We have 1.3 or 1.4 billion people to feed, and we have to develop. And I think just to consider the Greater Britain several hundreds of years ago, and they were polluted, but they resolved that. So in my opinion, that China can resolve the problem with the efforts of the Chinese people, because we love our country. So that's the reason I'm here today. That's the reason all Chinese people are here today. We want to learn the best knowledge from the development of the world. And we will go back to China to make it a better place to live, to make a better place for a law professor who can spend 6 months in Beijing with his head.
Thank you. That's a fair point. I think I've properly chastised. I agree with your sentiment. If you can do one thing, convince them to stop building a coal plant a week.
I have one thing to add to that. People don't know that China is like the #1 investor in renewable resources in the world.
That's true. They're kicking our behind on solar and wind, but they are building a coal plant a week. That's the problem.
Any other questions? Go ahead. You mentioned a 17% ROI on reducing, I guess that would be upgrading the grid, I imagine, to reduce efficiency or increase efficiency by 50%.
These are mostly end-use improvements in heating, cooling, industrial equipment. Smart grid is the key to renewables. Plug-in hybrids is the key to a smart grid implementing solar and wind and storing. So there's a whole suite of technologies and approaches. But the McKinsey report is the one I was referring to on the investment. That's a straight investment in end-use efficiency of energy use. Having smart meters would facilitate that for sure. But a lot of it is just replacing very wasteful buildings and equipment and appliances with state-of-the-art. Lighting.
That is solely a political, because it seems framed as a political issue.
It's largely a political issue because it's going to take the commitment of government agencies through regulatory policy and fiscal policy to promote efficiency approaches. Right now, the incentive is supply. The way that utilities make money is by building great big power plants and charging lots of money. And if you stop using electricity, that's not a good thing. They can't recoup their investment. They can't get their return. That's all wrong, isn't it? So the way that you change that is you decouple supply from charge, from price, and you tell the utilities you can make money by investing in efficiency improvements, not by building new power plants. I'm making it sound simpler than it is. It isn't simple. But it is what has to happen. And a lot of it is, frankly, government and politics. And are we going to make the break from fossil fuels or not? Yes?
So do you have any specific suggestions for people here who are depressed from your talk? What can they
Hemlock. No, I'm sorry. What can we do?
Individuals, yes.
Wow, there's a million things we can all do individually. Hire Bob Walker to do an audit of your home to start with. I mean, all of us use more energy than we need to. You know, home improvements, fewer travel. I don't travel hardly at all anymore. I decline invitations to fly across the country to give a talk in Seattle because you've got to change. If there's no big solutions coming along, you do what you can. So reducing the amount of carbon we each individually produce, there are various ways to do that. We could all become vegans. My students are always after me to completely break my ties to meat and get the hell off of that fossil fuel food and get on to healthier, better, organic, vegan, vegetarian approaches. That, you know, the food supply is a huge carbon footprint, enormous carbon footprint. So our dietary habits are another way that we could do this. Who we vote for, obviously. I mean, all the things that we can do individually, to be honest with you, are mostly feel good in terms of the scale of the problem, but they're nevertheless important because feeling good is important, and trying to feel like you're doing something is important. But really, you know, political action is what's required. It's just that straightforward. We've got to put people in Congress that believe this is a serious problem. Then what do you have government for? I don't think you have government to manage every little affair of life. But the one thing you want government to do is to prevent systemic failure, catastrophic failure. That's what we're looking at. So we've got to make our government work. It's not working now, but we've got to make it work. Yes, sir. One more, maybe?
What about the methane that is being released by the Earth because of permafrost, for example?
Huge problem.
Yeah, I mean, each methane pound is about 7 times more greenhouse gas as CO2. So here we have this methane being released because the Earth is warming, has been since 1850, and the CO2 is increasing. So if we make a big effort reducing this CO2 increase, to one of those scenarios you pointed out, then we might still be behind the 8 ball as a result of the increasing methane that comes about during the decades that we're making this big effort.
Yeah. The biggest problem, the biggest feedback loop the scientists are concerned about is that one, the release of methane from permafrost, and particularly Siberia. And we don't know how much time we have to prevent that. But all we do know is that if we don't prevent it, in the words of one scientist, it could put climate change on autopilot. It would be unstoppable. So we just have to act before that sort of thing happens. That's all we can do. I'm sorry if I depressed you, but maybe you're motivated to go do something.
Thank you.
Yes, thank you.